Once the Karnaugh map has been drawn and filled, the next task is to group it. And so in this case, our job is to group a completely filled Karnaugh map, and remember that the goal is to group it with groups that are powers of 2 in each dimension, so 2 by 1, 2 by 4, so forth, and also to group it with the fewest possible groups and the largest possible groups. Now, when I look at this, and by the way, don't forget you can overlap. You can cover the same cell more than once if you need to. That's no problem. Can't cover any zeros at all, but you can cover ones one or more times, and then you can also wrap around. So it can go across the vertical boundary. So for example, I could wrap around and then come back in over here, for example, or I could wrap around. It doesn't really help in this case, but I could wrap around the top and then come back in the bottom. And so that's what I mean when I say that you can wrap around the edges. Now, in this case, this is not going to be as easy as the ones that we saw in the previous examples. Sometimes, and I would encourage you to consider using a pencil when you're doing the groupings the first time, because sometimes you'll start to do a grouping and then you realize that maybe there was a bit of a mistake, that something could have been done a bit more efficiently if you had done it together. So I'm going to start by grouping these two right here because it seems likely that those are going to need to be in a group. That covers half of the ones just already in a single group. Let's look at the other two ones. This one right here in cell 4, I can't group with cell 6 or with cell 5 because those are both zeros. The only place I could group is I could wrap around. So I could go this way and wrap around with cell number 0, and that's just what I'm going to do. So I'm going to form a group of 2 here where I wrap around, going around to the edge there to cell number 0. That leaves cell number 7. Cell number 7 is an island. There are no other cells nearby that contain a 1. If I look to the left, it's a 0. To the top, it's a 0. To the right, it's a 0. To the bottom is the same as back up to the top because it wraps around. So all I can do is group that single 1. There's nothing wrong with a group of 1. It means that term, that product, is going to be a bit more complicated than it would otherwise be, but we didn't set the requirements. We didn't set the truth table, which led to the K-map. All that we can do is build the most efficient circuit possible that will satisfy that K-map. And this is the most efficient grouping to satisfy this K-map. Here's another example. Now, when I'm looking at this one, let's see. Something that I noticed right away is that all 4 cells in the left-hand column are all 1. So it seems likely that that's going to be a grouping there. I also see that I've got a grouping here, which is going to cover those 2. And now I've got 2 cells left. Now, what I could do, certainly, is I could wrap around the top and the bottom like that. No problem, that would totally work. But there's one thing that didn't come up in today's lesson that I wanted to mention to you, and that is that there is a special group. The 4 corners form a group. If you wrap around the vertical and the horizontal edges at the same time, you form a group of the 4 corners. Now, that is kind of tricky, but it also means that instead of having a group of 2 to cover cells 8 and 10, now I have a group of 4. And the larger the group is, the smaller the product term is going to be, and therefore the more optimized the circuit design is going to be.